10-1, line and angle relationships. We are told in the upper left-hand corner that M and N are parallel lines and T is a transversal. M is parallel to N, that's the way to write a parallel line, and T is a transversal. And a transversal is simply a line that crosses a pair of parallel lines. On the board, we have angles that are labeled 1, 2, 3, 4, 5, 6, 7, and 8. Those are not the angle measurements. Those are simply a way to label the 8 angles that are formed where transversal T crosses lines M and N. Want to look at line M and transversal T for a moment. We have angles 1, 2, 3, and 4. You need to know that angle 1 and angle 2 form something called a linear pair. And that's very important because that means angle 1 and angle 2 add up to 180 degrees. Angle 1 plus angle 4 also equal 180 degrees. If 1 and 2 add up to 180 and 1 and 4 add up to 180, I can rewrite the whole thing. Angle 1 plus angle 2 equals angle 1 plus angle 4, because they both add up to 180 degrees. 1 plus 2 equals 1 plus 4. If we subtract angle 1 away from both sides like we do with regular equations, the 1's go away, and we find that angle 2 is equal to angle 4. Very important to know that. Angle 2 and angle 4 are the same. If angles 2 and 4 are the same, what do you know about angles 1 and 3? They also have to be the same. Here we still have M is parallel to N. We're given a definition in the middle of the parallel lines. We're told that interior angles are angles that are on the inside of the parallel lines. So interior angles in this case would be 4 and 3 and 5 and 6. In the lower right hand corner, we're told that alternate interior angles are congruent. Alternate interior angles are congruent. So we are going to be looking at angles 3, 4, 5, and 6 because they are the interior angles, 3, 4, 5, and 6. Now we focus on the alternate. And alternate brings in transversal T. Angle 4 is on one side of the transversal. Angle 6 is on the other side of the transversal. So angle 4 is congruent to angle 6. Alternate interior angles are congruent. So we know that 4 and 6 are the same thing. And if 4 and 6 are the same, we can go with angle 3. What is its alternate interior angle? It's going to be angle 5. So we know that 4 and 6 are the same and 3 and 5 are the same. Remember on the previous board when we talked about how angles 1 and 3 are the same and 2 and 4 are the same? We're now looking at where that was just with transversal T and line M. Now if we look at transversal T with both lines M and N, I know that angles 1 and 3 and 5 are now the same. And if 1 is the same as 3 and 3 is the same as 5, is there another angle that's similar to 1, 3, and 5? It's going to be angle 7. And that also means angles 2, 4, 6, and 8 are the same angles. When we first saw this, there were 8 angles labeled. You now only need to know the angle measurement for 2 of those angles. Incidentally, these angles are labeled 1, 2, 3, 4, 5, 6, 7, 8 in this order. That's simply how I chose to label them. They won't always be labeled this way. You'll have to pay attention to how they're labeled. Another type of angle we're going to look at are something called exterior angles. And they are angles that are on the outside of the parallel lines. So we have 1, 2, 8, and 7. On this board, we're going to be told that alternate exterior angles are congruent. So we have exterior angles are going to be 1, 2, 7, and 8. But here we're told that alternate exterior angles are going to be congruent, which means in this case, angle 1 is congruent to which other exterior angle? Angle 7. And angle 2 is going to be congruent to angle 8 because it's its alternate exterior pair. On this board, we're going to be told that corresponding angles are in the same position on parallel lines with respect to the transversal. It's a very long definition to simply say angle 1 is congruent to and corresponds to angle 5. Angle 1 is in the top left-hand position where T crosses M, and angle 5 is in the top left-hand position where T crosses N. How about angle 2? Angle 2 corresponds with angle 6. Angle 3 corresponds with angle 7. And finally, angle 4 corresponds and is congruent to angle 8. Here, we're not going to have parallel lines. We're going to have something called vertical angles. I have this system here where I have angles 1, 2, 3, and 4 on the top. But we know something about vertical angles already. So angle 1 and angle 3 are vertical angles, and angle 2 and angle 4 are vertical angles. They form pairs of vertical angles. What do we know about vertical angles? Something we learned on the first board. If angle 1 and angle 2 is 180, and angle 1 and angle 4 is 180, we proved that angle 2 is congruent to angle 4. And angle 2 and angle 4 in this, where T crosses M, 2 and 4 are vertical angles. So, vertical angles are congruent. On the bottom of the board, we have something called adjacent angles. And adjacent angles are two angles that share a vertex and a common side. They do not overlap. So angle 1 and angle 2 are adjacent angles because they share a vertex and a common side. This situation, red angle and purple angle, are not adjacent angles because they do not share a common side even though they share a common vertex. Again, red angle and purple angle, in this case, are not adjacent angles. Although they share a common side, they do not share the same vertex. Finally, this board here, we're going to be looking at complementary angles and supplementary angles. So this is where you're actually going to see a little bit of math today, because on the top, we're told that complementary angles are two angles that add up to 90 degrees. So we should put a little square in here. So 1 plus angle 2 equals 90 degrees. You might have problems today where you're told that angle 1 is 15 degrees, so you have to find the measure of angle 2. And on the bottom we have supplementary angles. The sum of two angles is 180 degrees. And the word linear pair comes up from earlier. And finally on this board we have something called perpendicular lines. And perpendicular lines are two lines that intersect to form four right angles. That's why we call them perpendicular lines. So if this was line N and this was line P, N is perpendicular to line P. And it forms four right angles for the same reason. We know vertical angles are congruent, and so on. And finally, your homework today is going to be on page 496, problems 10 through 32, all of them.